Welcome back to my adventures in needlessly making my own parts to refurbish the Ansty Link suspension on my 1949 Ariel VB motorcycle. In this episode I'm working on the guide tubes and sliding member bushes. This is a build diary, not a tutorial. I'm a hobbyist, not a machinist, and constructive criticism is welcomed, or you can just take the piss. So, progress has been slow. First I tried to clean up the original ones, knowing it would end up a bit under diameter, but maybe that would be okay. I had a problem with this stuff's really hard, and trying to cut very shallow cuts on it using the carbide inserts really didn't work. Everything was glowing red, and it was cutting on the, it was catching on the oil hole here as well. So one of these ended up slightly bent, and the other one just ended up, you know, it's kind of all scratched up, it's undersized, but it was an interesting exercise in trying to turn between centers, but I never expected it to work. So rather than getting mystery metal, I bought myself some 1144 fatigue proof. Bought a 3-foot length of it, cut it in two, so I can get two of these out of each section. I only need two, but you know, guaranteed I'm going to screw some of them up. And sure enough, this first one that I tried to machine to size got a fairly good surface finish on it, but one of these ends is 1 thou undersized and the other one's 5 thou undersized, so that was a lesson. So the one that's on the machine here is, I took it down to 1 thou oversize and then finished off with the emery strip, which I haven't used before. I probably should have bought this stuff years ago. It's 400 grit emery, and then polishing it with 1500, a little bit 1500 wet and dry just for the final finish, and it comes up lovely, and it's all within a couple of tenths of the correct diameter, which is 7/8 inch. The reason for this stick out here is on this machine, the width of the table, because it's a mill as well as a lathe, is much wider than you would have on a normal saddle for a lathe, and also the tailstock does not stick out over this thing at all. So in order to get the reach into here, I have to put the tool over to this side of the table on this slot, and if I do that, I can't actually machine all the way up to the end here, so I have to have a fair bit of stick out here. Again, compromised machine. It's a 3-in-1. You're kind of stuck with this kind of limitation. But this has now been done on both ends, and it's ready for cutting off. This slightly undersized one I will also cut off, and I will use these for practice for the drilling operations, so that I can screw up this one before I go to the ones with a good diameter. This material cost me about 70 bucks. Buying the two parts from Dragonfly in the UK already machined would have been £18 each. So this is a hobby for exercise, not for profit. But that's where we're at. It's taken a while. One of the reasons for the delay was it's getting really terrible surface finish and so forth without cooling, and my old Cool Mist, which is the same age as the machine, it just gave up the ghost and stopped working. I could not figure out how to fix it with cleaning and so forth, so I went to Amazon, bought this thing, which seems to work fine. I have to figure out a better mounting for it, but I need to, you know, convert to mill mode to do that, so at the moment it's just cable tied. But that worked out pretty well, and getting really good cut on this. I do find with the carbide I can't take off like less than 15 thou diameter at a time, or it starts to rub and give really horrible results, so it needs to have a reasonable depth of cut. I probably need to learn how to cut my own high-speed steel tools for this, because that's probably a more appropriate tooling for this machine. But that's where we're at. So these are two sliding members. Although these are the same part number, they're not from the same years. This one, if you can see in there, there's an oil hole in there which has been drilled through and then blocked off. The reason for that is they simplified the design, I think in 1953-ish. They changed the design, 52, 53, and they went from the hardened chromed sleeve here in a bolt to just the bolt. And this bolt doesn't have an oiler in it. This has, it's not shown here, but there is actually a grease nipple on the top, and then it drills down in the middle, and then there's holes that come out to give grease. There's an indent in that shaft, and then there's holes in this shaft to allow the grease to get out to lubricate that main bearing. They simplified the whole mechanism here and took out that grease point, and instead they added this hole here to grease to the inside. I have the earlier everything else, so I can use the earlier type here, and then I'll just have 2 grease points for this side. I could drill this one to be compatible, but I don't need to because I have the earlier setup. If you do have the later setup here, you do want to make sure that your sliders have this grease hole that's in here. Otherwise you'll have no way to lubricate. You'll be lubricating here and there'll be no grease getting through to the main shaft. So if you are working from a mishmash of parts, or even if you've bought a bike that you think isn't a mishmash of parts, check that you've got at least one of those greasing mechanisms. I'm not going to bother upgrading this one to the later version. It's not necessary. I did check my 2 bores here, and they are not quite the same. They're a nominal 1 inch. This one is a little rougher, and it's about 2 thou over. And this one is more or less spot on 1. It's slightly over an inch. So this one's about 2 thou bigger than this one. So when I'm doing the bushings, I want to make sure that I don't mix them up, and I'll make these ones slightly larger. This is a material I'm working with. I tried setting it up in the lathe to see if I could grip at one end. I've got enough here for, I can make them about 1 3/8 inch long, which I think is about right. I don't have the actual original spec, but from the pictures I've seen, it looks like they're about 1 3/8 inch long, or 1.5. So I can get 4 out of this piece. And we're going to take most of this metal away because this is 1 1/4. Our normal outside is 1 inch, and our inner here is only going to be 7/8. So we're going to end up with a 1/16 of an inch thickness bush. So what I'm going to do is cut this in half because this is really too long to get good stability for machining, and then cut them in pairs to the right OD. Do the ID to close to the final depth, but not all the way to the final depth, and then part them off, and then put them in, and then bore through. Reaming would be an option, but I would need a 3/4 inch reamer, which for like 35 bucks, and then I might need a slightly thou over 3/4 inch reamer, which would be another 50 bucks. So I'm going to bore. This is a boring bar I have, which should be able to get all the way through with 2 screws on the post. It's fairly rigid. This is about the biggest boring bar you could get into that hole, so I may start off with a smaller boring bar, get it close, or drill, and get it up to there. That's the plan. Apologies for the weird strobing on this particular bit of sped up video. I have no idea what's going on. If anyone has any ideas, let me know. And if you like this content, please like and subscribe. It helps. So this is machining the bushes and trying to get the sizes right for the particular bore that we have in those sliding members. So my little baby arbor press is not big enough for this job in any way, so I have to come up with another solution. Okay, we'll give this a try. Might work. Yep, it's going a bit. There we go. One. That's where you need 3 hands. Okay, that looks straight. No, it does not. That looks straight. Of course, if I had a bucket of liquid nitrogen, like that Australian guy, this would go a lot easier. But this should do. That is in. Yay! So, quite happy with that. That is in, and we just need to do the other one, which I'm not going to film. So what we're doing here is bringing out the bores to about 20mm, because my largest boring bar, which is the one that can reach all the way through this, will not go in the initial hole size. It starts at 20mm, so I'm going to bring this out to 20mm using the smaller boring bar, doing both ends in the 3 jaw, and then I'll get it properly trued up in the 4 jaw, the big 4 jaw, and take it out to final dimension with the 16mm boring bar. This dodgy setup here is just to provide some counterweight to reduce vibration. We're not going that fast, but might as well. It doesn't seem to be dangerous as long as it don't stand in front of it, so we'll see how it goes. I haven't zeroed this boring bar yet. I'm just going to take it in and then take a reading and then set the diameter. Just do it by eye. Probably close enough. It's 20 millimeters, so that's good. So now I just flip it end for end, do the other end, and then do the other unit, and probably get another weight so I don't have to redo the cable ties for the other unit. And that will be that prepped for the main boring bar, which will be a whole different setup. So the plan was to use this 16mm boring bar, which is an S16Q MWLN R08, which according to various online information I got is a minimum diameter 20mm. So I've bored the bores from each end with a shorter boring bar out to 20mm, and then I went to mount this thing up and there was no way it was going to go in that hole. So I guess I have a cheap knockoff of this boring bar. So this connector up here was sticking way high, so it's been ground off, and there's been some metal ground off here, and it now goes in the hole and it just scratches off down to here, but then the main shank very lightly touches on the back, so it's not going to go in the hole unless it cuts its own hole. So I'm going to start off manually with a 40 thou above where I'm at, which is, you know, going to be out to 21mm. We're going out to 7/8, which is 22.2 something. So we've got plenty. We should be able to do it. But I'm going to go in manually with the pendant and find out how deep I need to go in the first cut. And then I'll set up my program to do both bores. So it's going to bore, wrap it to the other end, bore, come back out so it has clearance, come back out to the front here, and then come out to the side so I can measure. That's the plan. So we'll see how it goes. So things are falling apart. Let's try that again. I'm going to touch off Z first. Okay, so we're going to go in without power and see if we knock any of that blue off. How are we on the inside? Yeah, we're clear. Okay, I just have to hack my code and start boring at that depth. Okay, here goes nothing. And near the emergency stop, which is, no, I got one down here too. Oh God, that was close. That was closer than I measured it as being in terms of crashing, and it looked as if it was starting to scuff on this side. It was slightly scuffing on this side, so my bore, the other end, is probably slightly off, but we're not out to diameter yet. But we should be able to get away with this. If not, I'll just have to buy more bronze, I guess. So, a couple of spring passes in. Spring passes are getting very loud. Oh, there's a crap load of chatter in there. This is not going to work. So, now I know why people do line boring. So as long as I have a decent depth of cut, I get a decent finish. But start getting down to the smaller depths of cut, I get a crappy finish. And there's also a significant amount comes off with spring passes. So getting the final dimension here is going to be extremely hard. I'm very likely to bugger this up if I keep at this. Okay, on to the second one. Lessons learned from the first pass. This has been trued up with the dial gauge, so it's now fully parallel. It was slightly canted before, which messed things up. Dropped the speed down to 160, which seems to address the chatter issues somewhat. Which just means it's going to take a lot longer. So try and go and do the same thing, but it's going to be a lot slower, so video will be speeded up a lot more and skipped and all the rest of it. Oh, much better surface finish. So in the end, I was able to get it to work. This is the first one, as you can perhaps see in there. There was a whole bunch of chatter marks on there. 5-inch stick out on a 60mm boring bar. It's clearly not the right thing to do, but it's what I did. So the chatter marks, it is bearing on the high part, so I guess that might be grease retention. It might just wear out early and I'll have to do it again. But I did get a good sliding fit. This side does not have the chatter mark, so it was bored this way in, so most of the chatter was on the deeper end, which is weird because the stick out's the same on both, so why would it make a difference? And that became, I think I figured that out on the second one. I dropped the speed all the way down to 160 RPM and I got much smoother fit. And going in, I take off like 30 thou, and then I did a spring pass and it take off another 5 thou, and another spring pass would take off another 2 thou. So clearly a whole bunch of deflection in the boring bar. Chance of getting it chance of overshooting high. So in the end, with this one I stopped cutting like 10 thou before and started doing spring passes until it didn't take any more. Each spring pass is taking like 20 minutes because I'm going so slow. And then just gave it another couple of thou until the shaft would actually slide in, and then I stopped. And then at the other end, it was still too tight. So clearly I have a bit of taper going in. And as I don't have a tailstock, it's not a tailstock offset. It must be the tailstock would be that way. It must be the actual headstock must be slightly canted against the ways. It's very slight because I was able to bring this in with the emery paper and then get it sliding. So both of them now slide. They're very close fit, possibly too close for grease, but I figure that will wear in. I'd rather have too much material and have it wear off than have it loose and, you know, have to start all over again. So we'll give it a bit of oil, put it together. And these are also stamped. Got each of these stamped for which way up they go and which one they go in, because these are off from each other by about 2 thou in diameter. And, you know, there may be a little bit of taper going on as well. So as long as they slide up and down and they go in the same way, they're kind of hand fitted to each other, which is, you know, pre-industrial revolution, old school. But I'm gonna go with it. I think it'll be okay. Give them a little bit of oil. These are going to be greased, but I'm just oiling them just now for assembly purposes. And it should just go in there. And it's pretty smooth. As I say, very snug. Because I actually rubbed out the final tight spots and wore them in by hand. So these are too close tolerance for final use, but they'll run in. They're not binding. They should not bind, particularly not with actual suspension forces on them. They shouldn't bind. That one there might have to be redone because it may wear out early. They both go together. This one is slightly looser than the other one. This is the one I had to actually sand in, so there's a little bit resistance, but I think that'll wear in. These still need grease holes put in them in the shafts, but I think the next thing I'll work on is making a set of pullers or pushers for removing these old bushings in here and also in the other components. There's different sizes of bushings. I'll make up drifts that I'll be able to remove and insert bushings. Make those out of 12L14. So this has taken a long time to get this far. But I didn't destroy the material. I did get working components out of it, so I should be happy. But it did not go well. It did not go well at all.